Welcome everyone. My name is Pomsu Kim and I'm a PhD student in Kakao Brain. In this 5-minute video, I'm going to present our latest work on HOI detection, referred as HOTR. The task of HOI detection consists of finding and localizing all the interacting humans and objects that are visible in a given input image. A common way of characterizing HOI detection is through decomposing the task into two parts, localizing the bounding box for humans and objects, and associating the human and object with interaction labels. Early approaches in HOI detection compose these two tasks in a sequential manner by first performing object detection and then feeding every pair of the detected objects to a separate neural network to classify the interactions. Due to its intuitive pipeline, sequential HOI detectors feature stable performance. However, the pairwise neural network inference behaves as a serious bottleneck in HOI detection inference time. To overcome this issue, parallel HOI detectors have been proposed. Parallel HOI detectors define and capture a unique region called the region of interaction in parallel with object detection. For every region of interaction, we simply need to find the human and the object that best matches the detected region of interaction. Now, the time-consuming pairwise neural network is substituted with a simple distance or IOU-based matching. Compared to sequential HOI detectors, this enabled a remarkable speed-up in HOI detection. However, searching the correct object pairs for each interaction region results in a triplet search, which still leaves room for further improvement. To this end, we propose HOTR. The architecture overview of HOTR is as the following. As in HOTR, we first fit the image to a CNN to get image features. Since the transformer is permutation equivalent, we add fixed 2D positional embeddings in order to retain the 2D structure of the image. The resulting feature set is passed to a transformer encoder. For decoding, the key of HOTR is the two decoders, the instance decoder and the interaction decoder that decodes two fixed sets of learned embeddings called the instance queries and the interaction queries in parallel. Sharing the memory obtained from the same transformer encoder, the two parallel decoders decode the two sets of learned queries into two sets of feature vectors. The feature vectors obtained from the instance decoder are fed to a feed-forward network to perform ordinary object detection, while the feature vectors obtained from the interaction decoder simultaneously associates the detected objects with the appropriate label to form the final HOI triplet. The key of the fast and accurate detection of our model is how we simultaneously associate the objects with the appropriate interaction. We refer this process as HO pointers. Now let's take a look at HO pointers. The interaction feature vectors are fed into three fully connected layers that each infers the human feature vector of the interaction, object feature vector of the interaction, and the interaction labels. Then, we calculate the similarity of the feature vectors from the instance decoder and the interaction decoder. We obtain the object with the highest similarity, thus making the output of the interaction decoder to each point to a single human and a single object. We call this the HO pointers. Based on this architecture, HOTR obtains state-of-the-art performance on two benchmark HOI detection datasets. On a speed versus performance scale, not only does HOTR obtain state-of-the-art performance, but obtains the fastest inference time that is not only faster than all existing methods including parallel HOI detectors, but more than 5 times faster than the fastest HOI detector that have been previously proposed. Thank you for your attention.